Hello, this is Mrs. Reed, and today we are going to be reviewing for our polynomials quiz. So, first part here says, write each polynomial in standard form if needed. Name each polynomial by degree and number of terms. So remember, guys, standard form, you are writing these terms in alphabetical order, and it has to be based off of the highest exponent first. So you're putting the exponents that their variables attached with in alphabetical order and from descending order. So this one, there's no other term here, so that is already in standard form. So since it's already in standard form, we're just going to name this polynomial by its degree. So the degree here is the highest exponent on the variable, which is 3. And then number of terms, you're just counting all the terms in between your operation signs, so in this case it is just one term. Okay, next one. So see how I have a 6m to the first power and then a 4. So if this had to be in standard form, I would want my variable to the first power because that is the highest exponent first, and then my constant last. So in standard form it should be 6m to the first plus your 4. And then our degree is whatever highest exponent we have, which in this case is just 1. And then your number of terms, again, are separated by your addition and subtraction signs. So I have 1 term, 2 terms. Number 3, so notice how I have just an x to the first power, an x to the second power, and just a constant of -2. So standard form, I'm going to put my exponent with the highest degree first, so that would be 8x squared. Then I'm going to have the 10x to the first next, because that's the next highest exponent, and then lastly will be our constant of -2. Okay, so since that's now in standard form, I can now say what my degree is. So the highest exponent that I have is this 2. And then number of terms is everything separated by addition and subtraction signs. So I have 1, 2, 3 terms. Okay, and then the last one here, so my 9x to the third needs to come before the x squared because it has a higher exponent. Remember though, with the subtraction sign before it, it's really a -9. So your standard form would be -9x cubed, and then your 7x squared would go next. So my degree, the highest exponent here is a 3. And then the number of terms, everything separated by addition or subtraction signs, I have 2 terms. Okay, now moving on to simplifying expressions by adding, subtracting, or multiplying as indicated. So remember, guys, when it's showing addition in between your polynomials, you're just going to combine your like terms like normal. And I like to combine them by going ahead and putting them into standard form so that I don't have an extra step to do afterwards. But just know you don't have to do it that way. Okay, so the first thing that I see here is a 3k to the second and a -4k to the second. So since they have same exponent to the same power, I can combine those together. So 3 plus a -4 is just a -1k squared, or just a -k squared. Then the next thing that I see is a -3k and a +5k. So they have same variable to the same power, so I can combine -3 plus 5, which is a +2. So that would be 2k. And then the last thing that I combine are my constants. So I see a +7 and a +4, so that would give me a +11. And now it is in standard form. Okay, next one. So remember, guys, when you see subtraction, you have to first change that subtraction to addition by using your distributive property, by distributing this negative to every single term on the inside of your second parentheses. So my first polynomial here is going to stay the same. So 7x squared plus 5x minus 8. And this subtraction sign will now turn into a plus sign. And a negative times a +2x squared is a -2x squared. A negative times a -7x is a +7x. And a negative times a +2 is a -2. So after you do the distributive property, you are now just going to go back to what we just did for number 5. So just start combining like terms. So I can combine my x squareds together by taking 7 plus a negative 2, which is a positive 5x squared. Then I have a 5x and a 7x that have the same variable to the same power, so that would give me a positive 12x. And then I have my constants that I can combine together, so a negative 8 plus a negative 2 is a negative 10. Okay, so I want you guys to go ahead and pause the video and then try number 7 and number 8 on your own. Very similar to what we just did for number 5 and 6. Remember, if you see a subtraction sign in between your two parentheses, you have to first do the distributive property and then you can combine like terms like normal. Okay, so go ahead and pause the video and press play when you're ready for the answers. Okay, for number 7, you should have first done the distributive property by distributing that negative to everything on the inside of your second parentheses. So your 3x squared plus 8x plus 6 would stay the same, but then your second parentheses would turn into a negative 1 plus a positive 5x. Okay, and then you can just start combining like terms. So my 3x squared is the only x squared that I see, so I'm just going to drop that down. I see an 8x and a 5x, so I'm going to combine those together, and that will give me 13x. And then the last thing I can combine are my constants, so a 6 plus a negative 1 is a positive 5. All right, this one, notice how it's already addition, so we don't have to do any distributive property or anything. So I'm just going to combine like terms like normal. Remember, guys, if there's a variable to a power that doesn't have a coefficient in front of it, you can just put that imaginary 1 there. So when I add my b to the fourths together, it's a 4 plus a 1, so that would give you 5b to the fourth. I have a negative 3b to the second and a positive 3b to the second, so negative 3 plus 3 is just 0, so those will cancel each other out. And then the only last thing that I have here is the 6b that I'll just drop down. So those are your answers, so good job if you guys got that. If you did not, please make sure you fix your mistake, and we're going to go ahead and move on to 9 and 10. So 9 and 10, notice how these are multiplying because two parentheses are shoved up next to each other. So this is where we will be doing the distributive property by taking your first term in the first parentheses times everything on the inside of that second parentheses, and then you'll do the same thing with your second term in that first parentheses. Okay? So when we take 2a times a to the second, remember you're just adding your exponents, so that would be 1 plus 2, which is 3, so that would be 2a to the third. 2a times a negative 3a, so you multiply your coefficient, so 2 times a negative 3 is a negative 6, and then a to the first plus an a to the first is an a to the second, because again you're just adding your exponents and keeping the same base. And then a 2a times just a 6, you just multiply your constants, so that would give you a 12a. Okay, now we're going to do the same thing with our second number in our first parentheses. Remember, guys, this is a negative 3 because of the subtraction sign before it. So negative 3 times an a squared is a negative 3a squared. Negative 3 times a negative 3a would give us a negative 9a. And then a negative 3 times a positive 6 is a negative 18. Okay, so once you do the distributive property for both of your numbers, you can now just start combining like terms. So I only see 1 2a to the third, and to put it in standard form, again, I have to have my highest exponent first. So that would be my first number in standard form. I see a negative 6a squared and a negative 3a squared, so I'm going to combine those together. So negative 6 plus a negative 3 is a negative 9a squared. I see two variables that just have a, so I'm going to combine those. So 12 plus a negative 9 is a positive 3a. And then I just have my single constant left, so I'll just add that on. And that is your final answer. All right, so same thing with number 10. You're going to take that first term in your parentheses and multiply that times every single term in your second parentheses. So a 7n times a 2n squared, again, you're just going to multiply your coefficients. So 7 times 2 is 14. And then an n to the first to the n to the second, multiply those together. So you're just adding your exponents. So 1 plus 2 is 3. Then your 7n plus your 2n. So 7 times 2, again, is 14. And then n to the first times n to the first, just add your exponents, would be n to the second. And then 7n times 5 would just give you a 35n. Now looking at your second number, so do the same exact thing. So 5 times 2n squared would give you a 10n squared. 5 times 2n is just 10n. And then 5 times 5 will give you 25. Okay, so after you do the distributive property, we're just going to combine like terms like normal. So I only see 1n cubed, so that is going to stay 14n cubed to begin with to write it in standard form. I see 2n squares that I can combine together, so 14 plus a 10 would give me a 24n squared. I see 2 n's that I can combine together, so 35 plus 10 is 45n. And then my last term is just that constant that I'm going to add on at the end. So that is my final answer. Okay, so still going here. So 8x plus 3 squared. So that just means we're taking 8x plus 3 times 8x plus 3. So this is where we talked about using FOIL. So remember, FOIL means you are using the distributive property by first multiplying your first numbers together. So 8x plus 8x would give you a 64x squared. Then the O in FOIL means outer. So you're going to take that first number times the outer number. So 8x times 3 would give you a 24x. Then the next word in FOIL is I, which is inner. So you're going to multiply your two inner numbers together. So 3 times an 8x is a 24x. And then lastly, the L means last. So you're going to multiply the two last numbers together. So 3 times 3 will give you 9. And then you just have to take one more step by simplifying your two like terms together. So I see a 24x and a 24x that I can combine together. And that will give me a 48x. And that is your standard form. So again, FOIL is first, outer, inner, and last. Okay, so doing the same thing here. So I'm multiplying two binomials together. So a 7m, so using FOIL, I'm going to multiply my two first numbers together. So 7m to the first times an m to the first, just add your exponents. So that would be 7m to the second. Multiply the outer number times the first number. So 7m times 3 is a positive 21m. Now you're going to multiply your two inner numbers together. So negative 3 times m is a negative 3m. And then multiply your last number. So negative 3 times a positive 3 is a negative 9. And then you're going to have to combine your two like terms together by taking your 21m minus your 3m, and that will give you an 18m. And that is your final answer. Okay, so again, I want you guys to go ahead and pause this video, and I want you guys to finish out 13, 14, 15, and 16 on your own. So on 13, 14, 15, 16, you guys are just using FOIL. So again, go ahead and pause the video, and then press play when you guys are ready for the answer. Okay, so number 13, when you guys did your FOIL, 5x times 4x was 20x squared. 5x times a negative 1 was a negative 5x. 6 times a 4x was a positive 24x. And then 6 times a negative 1 is a negative 6. And then when you guys combined your two like terms together, you should have got a positive 19x. Okay, next one. So 3k times a 3k would be a 9k squared. 3k times a negative 8 would be a negative 24k. 8 times a positive 3k would be a positive 24k. And then a 8 times a negative 8 would give you a negative 64. And then when you combined your two like terms together, they did cancel each other out because a negative 24 plus a positive 24 is 0. So you should have just been left with 9k squared minus your 64. Okay, so next one, 3v minus 2 squared. So that means you're going to take 3v minus 2 times 3v minus 2. So again, you're just doing FOIL. So 3v times 3v is a 9v squared. 3v times negative 2 is a negative 6v. Negative 2 times a 3v is again, no, I did that right, is a negative 6v. And then your negative 2 times the negative 2 is a positive 4. So again, you're just going to combine your two like terms together. So a negative 6v minus a 6v will give you a negative 12v. All right, and then the last one here, so 7m times a 4m is a 28m squared. 7m times a negative 8 is a negative 56m. Negative 2 times a 4m is a negative 8m. And then a negative 2 times a negative 8 is a positive 16. And then again, you're just combining your like terms. So this negative 56 minus 8 will give us a negative 64m. And then we'll just attach that plus 16. Okay, so those are your answers. So good job if you guys got that right. If not, please fix your mistakes. Alright guys, and then the last thing is just this little table here. So I gave you a polynomial. You need to set it up into standard form. You're going to tell me what the degree is. So remember that will be your highest exponent. Then you'll tell me the number of terms. So how many terms are separated by addition and subtraction signs. And then these two are what we just did on the front side with the front problems. So you guys should be good to go with that. Remember guys, your leading coefficient will be the first coefficient that you see in your standard form. So remember guys, coefficients are attached to variables, so you will just tell me what your leading coefficient is. Okay guys, so for the first one, when you see just one term, that is the only form that you can put it in, so that standard form would be 12. Notice how it does not have any variable to any power, so that means that it does not have a degree. Your only term here is that 12, so that means that you just have one term. And then again, guys, leading coefficient, a lot of students would put 12 here, but remember guys, coefficients have to be attached to variables. So since 12 is not attached to a variable, there is actually no coefficient. Okay, so next one, so again guys, I just have one term here, so my standard form would just be that negative 4x. My degree this time, so remember guys, when I just have a variable, my degree is still to the first power, so that is the highest degree that I have. I once again only have one term. And then my leading coefficient this time, since I do have a number attached to a variable, is going to be negative 4. Okay, so next one, so if I want to put this in standard form, I would have to move this 3x first because that is my highest exponent to a power. So my standard form would be 3x to the first, or just 3x, plus or minus my 6. It would be plus negative 6 or just minus 6. And that is now in standard form. So again, your degree is to the highest power, so my degree here is just 1. Because of my imaginary 1 that I could put up there. Number of terms, this time I have 2 terms separated by addition or subtraction signs. And then my leading coefficient is attached to my variable, so that would be 3. Okay, so I want you guys to go ahead and finish this table, so go ahead and pause the video and then press play when you're ready. Alright guys, so for your next one, oh, Mrs. Reed needs to put a plus sign there, so that was my fault. So what we need to do here is we need to first move that 3x cubed to the front. And then I can actually combine these two together. So my 2x plus my 5x would just give me my 7x. So this time my degree, my highest degree is that power of 3. Again, I have two terms. And then this time my leading coefficient would be that 3, because that's the first coefficient that I see. The next one, your first number should have been that 15x to the 4th, because that had the highest power. Then your 7x cubed, and then your x squared. Which means your highest degree, so your degree would be that 4. Number of terms should have been 3. And your leading coefficient would have been 15. And then finally the last one, so your first term should have been that 10x squared, then your minus x, and then your minus 9. So your degree, the term with the highest, or the variable with the highest power is 2. Number of terms separated by addition or subtraction signs is 3. And then your leading coefficient is that 10. And that is it. So if you guys have any questions, please ask your teacher. Thanks.